So welcome to this session in Snyk's DevSecCon 2025. And in today's session, I would like to talk about agentic security. So the kind of title of the session is Agentic Applications Need Agentic Security. And we've been talking far and wide in the market and with customers around the new AI applications they're building, the new agents they're building, and what it means for them to secure this. So in the next 25 minutes, you're going to learn about how you can achieve agentic security, why it needs to be agentic, and what is Snyk doing about this. So it's clear to us at this point, about 2, 3 years into the large language model, generative AI transformation, that AI is impacting everywhere in the software development lifecycle or SDLC. Now, we talk around the market and in the industry, we're hearing really three main challenges around how AI is impacting software development. In the first challenge, we have questions around how do we use AI to accelerate DevSecOps? So this is your security teams thinking how you can use AI to accelerate how you secure sort of the traditional risk surfaces of your company. There's the middle challenge shown on screen where the challenge is more around how do we secure AI-driven development, or more colloquially known as vibe coding. So if you're watching this, chances are you yourself are using some sort of AI IDE or maybe an AI CLI, where it enables you to take advantage of large language models to create and generate code and generate full-on applications. And then, of course, the third challenge and the most new challenge of all is how do we secure AI native software? So AI native software, we can kind of really define this a little bit more. AI native software really is just any kind of application or any software that has a large language model or generative model that's within its key decision-making flow or its business logic. Sometimes you might hear this as you're building an agent. Sometimes it's a chatbot. Sometimes it's just called an AI application. In any case, this is a new thing that everybody's making. Everybody's keen to experiment with this. Businesses are getting real traction and real revenue from this innovation, but somebody needs to go secure it. So this is the focus of our session today. Well, if we look at the challenge of securing AI native software, actually, it has kind of transitioned from what is a novelty and then what is the experimental lab innovation kind of technology to something that has real world consequences. So if you just look at the statistics of how generative AI is being deployed, but also like its security risks, we see that 72% of the market say that they're struggling to maintain visibility into embedded AI. 33% of a survey says they've already been targeted by a prompt injection attack. So not only is the future here, the future is very much impacting everyone in terms of when you're putting AI into your organization, when you're putting AI into your apps, when you're building AI agents, real security risks are very much present and something you need to deal with. Because of all of these market changes and new market trends, we actually spent the last 12 to 18 months really digging in with our customers, with our partners, and with our research teams on what are we thinking and how's the market feeling around securing AI native apps. So when we talk to them about their challenges, we really see three things, right? So the first thing is the visibility challenge. The second thing is the lack of expertise. And then the last thing is the scattered AI security landscape. We can look at this one by one because I think it's quite important for us to really hone in on what the problem is before we go attempt to outline or even build a solution. When it comes to visibility, there's an exploding amount of new technology coming out every day. So it started really frighteningly to ourselves and a lot of the market. Early this year, open source models were a big concern, especially when They're open source models from different kind of markets. In the middle of the year, Model Context Protocol, or MCPs, became a big thing. There's a huge amount of adoption, lots of developers experimenting with it. So in a market that's moving this fast, the visibility challenge really boils down to it's very difficult to know where AI is being used by teams, because you can have developers experimenting here, you could have innovation teams deploying something as a prototype there. Not only is it difficult to see where it is, it's also hard to understand, is this okay to use or is it not okay to use, right? There's a difficulty in assessing the risk posed by these kind of innovative technologies and disruptive technologies. And because of this balance, it's very hard to both enable innovation, but also enable security, right? Like it's very hard to not block the pace of progress, but still stay secure. So that's the visibility challenge. In addition to that, because this is so new and moving so fast, a lot of teams tell us that there's a lack of expertise. So people are finding it hard to understand, well, what is agentic security? How do you secure agents? How do you secure AI? And you don't have traditional concepts like CVEs, or you don't have traditional concepts like CVSS. You don't have traditional concepts like SBOM, according to these new things. And so the new threats and new attack vectors are still being understood. Um, AI adoption is really kind of creating this massive problem in the market, and there is not a huge amount of tools and frameworks for us to really understand this. So that's where the lack of deep AI expertise really bites us. Last but not least, the third challenge is really around the solutions available to solve AI security. There is a lack of one-stop shop tooling to help you secure all of these risks. There's a lack of tooling that stays constantly ahead of the market to understand what are these new threats, what are these new attack vectors, and how do we protect them. And of course, because this is a very hot, new, innovative area, the landscape is riddled with a huge amount of startups, which is very exciting, but also presents a huge amount of risk because you are both procuring or trying or POCing a large number of startups, which is difficult to manage, but also the startups themselves can have uncertain futures, and that creates another level of meta risk along all of this. So when we combine the visibility challenge, the lack of expertise, and the confusing landscape, that creates a huge problem in the market of how do we secure AI native apps and agents. So now that we've understood all of these challenges, Snyk is proud to present Evo, the Agentic Security Orchestrator. So we looked at all of these challenges that I covered in the last few minutes, and we think that because of the non-determinism of the problem, because of how fast it's moving, because of how much context you need to really build a good solution to answer to the challenges that I've shared in the last slide, agentic applications really need agentic security, right? So you need to use agents to secure agents. This is why Evo by Snyk is a team of agents. So overall, we're presenting this and thinking about this as an orchestration layer for AI security. AI is something that moves very quickly. It moves non-deterministically. Your agents can call tools. It can access databases. So you need the agent to be able to secure by orchestrating different sub-agents and different task-oriented agents to solve the problem at hand. If you look at Evo by Snyk, what you will find is, first and foremost, we have the workflow and reporting agents at the very top. And this answers the need for us to get ad hoc and just-in-time personalized answers and workflows to solve some of the security challenges that AI presents you. Within Evo, we also have task-oriented agents that could be orchestrated by the workflow and reporting agents. This includes things like the discovery agent that addresses visibility. It includes things like red teaming agent, AI risk registry agent, threat modeling agent, and MCP scan agent that addresses new threats and attack vectors in the market. We have policy and fix agent to address the lack of expertise in actually really dealing with this. So Evo by Snyk can give you a proactive approach in your AI security posture. And so to really tie this together, let me show you what Evo by Snyk looks like. As we enter Evo by Snyk, we're presented with a familiar agentic interface, and we can notice that Evo by Snyk is a team of agents that could secure your apps, your endpoints. You could build your AI inventory, and you could use policies to enforce different guardrails in your overall security posture. In the middle of the screen, we see an overview dashboard of what Evo by Snyk is finding in your applications and endpoints. You have an overview of AI endpoints, you have overview of repositories of AI, and you can look at your overall AI risk score. And of course, the most important of all, as Evo operates and as you use Evo more and Evo learns about your environment, the whole idea is it can leverage all of its orchestration to help you reduce your security issues over time. On the right, we have a chat interface that lets you interact with the workflow and orchestration agents of Evo. And one of the key differences you would see, and this really directly addresses the challenge that I mentioned before around the lack of expertise or how the market is moving so quickly. Customers are finding it critical for somebody to teach them how to do AI security or at least share some best practice. Unlike other agentic experiences, you don't prompt Evo, Evo prompts you. So Evo gives you suggestions based on your security posture to progress in the next steps. Of course, you can still prompt Evo, but the idea is Evo continuously assesses your security posture. It looks at the data, looks at the context, and gives you actionable next steps. So here we can see that Evo has suggested 3 next steps for us. So the first thing is to make sure that we have coverage of scanning, which I think is very sensible. So let's take a look at that. As we click into this suggestion, we see that Evo has suggested to us that we want to make sure that all possible developer machines and endpoints are covered by the MCP scan agent and identify any AI usage on them. We can see that Evo has both navigated to the right page in the Evo application, but also used the reporting agent to personalize some of the report based on our intent and our context. And in the middle, if we just look at the report very quickly, we have an overview of our endpoints and the coverage. We can see individual endpoints and any issues that we might have on these endpoints. And most critically, if there are endpoints that are not covered by our current scanning, we can see the reasons why. So we have a failure reasons reporting here where we can say, oh, okay, so some of the endpoints are not being covered because of different reasons, or maybe the MCP scan version that they have is outdated. So this gives us this visibility. Now, after we have performed this, what Evo suggests to us to do is to move on from looking at coverage in terms of endpoints and now going to look in terms of coverage in terms of repositories and applications. So let's take a look at that as well. As we accept this suggestion, what we see is Evo says, hey, show me the AI bill of materials across all the repositories. And you can see Evo orchestrating the discovery agent to deliver this, engaging things like our SCM integration, looking at code in the repositories, and building AI bills of materials to aggregate the data you see in the middle. And just to kind of go over some of what we can find with the AI bill of materials quickly, of course, we identify what repositories are covered for you and what technologies we're finding in those repositories. But then you can also see an aggregated view of AI models that you're using in your company, frameworks that are AI first, tools that some of your agents are calling, MCP servers and MCP clients that your team is implementing, agents that your teams are building, and data sets that they depend on. So all of this gives you a really comprehensive overview of what's happening in your build and what's happening in your code repositories in the same way that the MCP scan agent helps you see what AI is being used in your endpoints. Now that we have this validation that coverage is achieved in both endpoints and apps, the next thing that Evo suggests to us is to try out our threat modeling agents. As we click the threat modeling agent, what's happening right now, it's with a very familiar search or retrieval kind of term where we're saying, can I see the threat model of a particular app? So here's a customer service RAG app, and Evo then coordinates and orchestrates the inventory agent to find this threat model, and the threat model agent, of course, serves the threat model. So here in the middle, you can see a very familiar diagram that it should be familiar to any security professional, threat model of a RAG application. And of course, because this is actually ran on a scheduled timer every hour, every day, we already have the threats that are coming from the threat model, and this threat model is automatically done based on some of the data on Evo's SCM integration. So with this, and then with the threats in the middle, and of course, some of the more common workflows is I see this threat model, I assess it, and actually I find that there's something that I need to change. So what I can do is I can ask Evo to make this change for me. Evo is orchestrating the threat model agents to make this happen, and you can see that the threat model has updated based on the threat model agents' work in the background. Now that we have the threat model built, the next step is for us to check out the red teaming agent. So let's take a look at that. In the red teaming agent, again, we have certain targets. So we can select the customer support RAG agent again. So let's take this guy. And one of the challenges that we hear from the customers when they try, let's say, open source red teaming tools or general purpose evaluation framework is that setting up some of these red teaming exercises is actually really complicated and complex. And typically, users find themselves filling in pages and pages of forms, really needing to think through every single nook and cranny, and then really none the wiser around why they're filling it in that way. So with Evo, what you can do is you can actually leverage the threat models and leverage the AI bills of materials and leverage some of the unstructured text and unstructured context that you're feeding it, and it would help you configure your red teaming scan for you. So here you can see that there's an automatically generated red teaming scan. We have actually asked it to improve the configuration, and it has assembled an attack library of things to scan for based on our configuration. So if we look at the configuration and we scroll down, we can see that Evo has decided to map our attacks according to the OAuth LLM top 10. And helpfully, we have some attacks. We have a preview of how many tokens they're going to consume, the cost they will cost to run this target, just so you know that as you're capturing some of the behavior and runtime vulnerabilities of your agents, you're not overpaying for this testing. You can also see that Evo is configuring also the scoring for you. So the scoring is really important here to evaluate whether some of these attacks and some of these scans have succeeded. And as you know, because agents produce non-deterministic unstructured outputs, having a robust set of evaluations for your red teaming is super important. Now that I've evaluated and reviewed the attack plan, what I can do is actually approve this plan. So here I have a very familiar plan interface. I can just approve this. And what's happening here, it's Evo is orchestrating the red teaming agent to perform the individual scans that you're seeing here. So as I'm talking through some of these attacks that it's simulating towards your target, it's progressing through the red teaming scan, and it's reporting back on some of the findings along the way. When the red teaming agent has completed, what it does is it would actually create you a red team summary. So here we have a very simple overview of the risk score of the target. We have a distribution of what kind of new threats and attack vectors we're finding on the chart on the right. And of course, we have all of this captured as issues inside your Evo context. Now that we have looked at your coverage, we have looked at threat modeling, we have looked at your AI bill of materials, we've looked at some of the issues you can find with red teaming, let's actually put this all together and look at your overall risk. So in your overall risk, this is where the reporting agent comes to shine. As you can see here on the right-hand side, Evil is orchestrating 4 different agents to understand the different risks inside both your applications and your endpoints. Finally, the reporting agent dynamically takes this and makes a personalized dashboard for you, as you can see in the middle, where you have all the risks, whether they're issues or threats, ranked in terms of severity and presenting you in a single pane of glass. With this, again, Evil gives us a plan. And so what this plan suggests, it's actually we start dealing with some of the criticals and highs in this table and actually use Evil to orchestrate the fix agents to start addressing some of these issues. So let's approve this plan and see how it works. Here, Evil has taken all of our issues and created and ranked them by criticality or severity. And it starts getting the fix agent to really generate the next steps or the workflows to address some of these issues. So let's dive into what's really happening. In the first issue here, around a particular model, what we're seeing here is Evil has decided that this is something that a human developer needs to fix. So the fix has been routed to an AI-generated ticket that will land in the right developer's board, and the developer can go address this. And of course, with our Snyk, we can understand when this is fixed and record that from now on. In the second instance, Evil has actually decided that we do not need human intervention to get this issue remediated, and all we need is an AI-generated patch. So here you see that Evil has coordinated with the fix agent, and what it has done is generate a patch for this issue, and this issue would get remediated based on an automatic pull request that fix agent would work with your SCM integration to open by MCP, and this would help you solve this particular critical issue in your applications. Lastly, we have an example where Evil actually understands that this is neither a developer ticket nor a GitHub PR, but actually this is something where we want to put a new control or new blocking configuration in the CI/CD pipeline. So it could also orchestrate with your CI/CD pipeline increasingly through the model context protocol and generate a new policy configuration in the pipeline so that we start having blocking behavior for some of these recurring issues that we're seeing. Now that we have gone through all of this, we can see that all the issues have been assigned a fix agent, and you can have a new session around this. And all of this is running in the background, whether it's generating a new ticket for the developer, whether it's generating a fix PR, whether it's generating a new configuration change. All of this is automatically progressing you in terms of remediating more of your issues and overall improving your security posture over time. And that's Evil by Snyk. So now that we have seen what Evil by Snyk looks like, what should we do next? So here's 3 steps to understand your AI native security risk and how you can help secure your agents that more and more people are developing in your company or in your team. So the first thing you can do to address visibility is we already have a Snyk AI Bomb tool, AI Build Materials tool that's available today to existing customers. When it comes to AI development, you can leverage our open source MCP scanner to identify MCP use within your development teams. And getting started is simply scanning the QR code in the middle here. Last but not least, if you want to build AI skills both for yourself or in your team and company, do subscribe to Snyk Labs for updates on AI security research and additional product development. So today we looked at the agentic applications and why it needs agentic security, the different challenges around visibility, expertise, and tool sprawl, and how Evil by Snyk solves all of these issues. Thank you very much for joining us today at Snyk.